You are now listening to the Building with AI Promises and Heartbreaks podcast, brought to you by Solid.
Hi, Tomasz. Thank you for joining us today. Today we have another episode of Building with AI Promises and Heartbreaks. How's it going, Tomasz?
It's going great, Yoni. Thanks for having me on. I appreciate it.
Thank you for joining. So I wanna share a couple stories with the audience first before we get rolling. So first of all, uh, many years ago, I sat at an office of a venture capitalist called Kirill Shankman in New York, and he had a book behind him of developing with Scala. And this is when Scala was like a big hit. This is many years ago, so I think 2012 or something like that. And up to that point, I've never seen a venture capitalist have a coding book. And it's like, hey, what is this? It's like, oh yeah, I code like, and he's got this very specific way he talks. Like, yeah, I built my own app, and all of our portfolio is tracked by an application that I built in Scala and all that. And I was amazed. I was like, wow, this is crazy. A VC that can code. And I kind of left that in the back of my mind. And then over the last 12 months or so, in your blog, you got deeper and deeper and deeper into the weeds and the technical aspects. I was like, wow, this is amazing. It feels like, I really enjoyed reading this, and I really enjoy having someone who understands the market and the investments and all that, and then also goes down into the weeds. And so if any of our listeners is not yet following your blog, which is probably unlikely since you've been at it, I think now for 13 years. Is that right? 13 years?
That's exactly right. Yeah.
So if you are not following Tomasz's blog yet, I suggest you pause this episode for a moment, go to Tom, Tom, and then TUNGUZ.com. So TOMTUNGUZ.com, and subscribe to his blog there. You're going to get 3-4 posts a week. They're generally pretty short, easy to read, super interesting. I enjoy every single one that comes out from you, and I've been a subscriber for many years. So,
Thank you.
It's a real pleasure to have you here, Tomasz.
No, the privilege is mine. I'm really keen to talk about all this stuff. It's changing so fast, and I hope we can talk about some meaty topics.
Yeah, fantastic. Cool. So let's maybe start for a moment. Tell us a bit about Theory Ventures, your past, and what kind of brought you into experimenting with AI over the recent history.
Yeah, you bet. Started a company when I was 17 that got me into startups, and then I went to work for a company that was founded by 3 alums from my university in about 14 and a half, and then started Theory. And Theory is a venture firm where we build very concentrated portfolios of companies. We invest primarily in AI and crypto, anything that's powered ultimately by data. And a key part of our lens on the world is we really like to go extremely deep. And we think if we can understand the technology, then we can have a much deeper view on where the world is going. Not to say that we'll ever know as much of the technology as the founders that we back, but by using it, we can discover, okay, and I can walk you through a story. We've been deploying MCP, and as a result of deploying MCP, Model Context Protocol, inside of Theory, we've stumbled across lots of different points of friction that we think others will anticipate as they progress on their journey. And so as part of that, we have a research team, which we call the intelligence team. It's headed by Lauren, who built a healthcare practice at Palantir. We have a head of AI who was head of AI at 3 unicorns, and many technologists on staff. And we're based in San Francisco in the Ferry Building.
That's a great location, actually. I love the
Ferry Building. It's a great location. It puts a smile on everybody's face. It smells like baked bread in the morning and ice cream waffle cones in the afternoon.
Exactly. And some good coffee there. And then you got the market and the view. That's an amazing place. Okay. So first of all, a question. When you're talking about building these things, are you building just for the purpose of studying the technologies and then understanding what frictions and gaps, or are you actually building something that's useful for you guys?
Yeah, we build a lot of tools so we build many tools. Some of them turn out to be very useful and are now production apps within Theory. And some of them are experiments that ultimately don't end up working out. But most of them have product requirements documents. We're designing with full engineering mentality.
Amazing. Can you give us an example of one of those?
Yeah, I mean, the one that I think is really tangible. I don't like listening to podcasts because so when I was at Google, Marissa Meyer used to talk about information density, and her goal in designing the Google homepage was maximizing information density on the page. And if you know that about her philosophy, you look at the 10 blue links and you see the impact. And I just think the information density in podcasts, there's a lot of great information there, but the information density is lower. And so what you can do is, and we've built this, is a production system that actually has a list of different podcasts, transcribes them, runs them through a prompt, and then sends out an email every day. And that is really useful. It also finds companies that we haven't heard of, adds them to our CRM and our tracking list, and automatically enriches them and scores them and those kinds of things. And so that's an example. Newsletters, we do the same thing. So we subscribe to many different newsletters and then automatically ingest and pull them apart.
Yeah, there. I think it was last week I had a guest here, Minal. She's the VP of Data of SurveyMonkey. And towards the end, she talked about a similar thing. She said, I'm following 10, 15 different Substacks. And so what I do is I have it all go into an AI. AI summarizes it, gives me the key points, and sends it to me with links to the parts that might be interesting to read. And to your point, information density is a challenge. By the way, you're really good on information density in your blog posts. They're very short. I hate reading long posts. I have AI that summarizes every single Substack I'm a subscriber of. They all go into the same AI through RSS, and it summarizes them. Your blog is the only one that doesn't go into any summaries because it's
Thanks.
4 or 5 paragraphs, and you get the point across. So I'm in agreement with that.
Okay, so this makes me wonder.
Yeah.
Okay, will there be a post that I write for humans and then a post that I write for AI? Because I know whatever, let's say 50-50, maybe, I don't know what the ratio will be, but half of the consumption will go through AI. And so I want the AI to read or extract different points. And then if that's really a dominant consumption mechanism, then like, why write the original post? This is something I've been wondering about. Do you have a view?
Yeah, I do. You're going to have 2 formats. So what's
You
going
think
to
so?
happen
Yeah.
is you're going to have a format for machines and a format for humans. The same thing's going to happen in websites. Like websites are going to get more and more concise and easier for humans to interact with when humans are interacting with them. But also there are going to be versions that are very machine facing because you're going to want, ChatGPT to promote your website, and you'll be, for the user to be able to and buy the product just like what they released. So there's going to be 2 versions, I think, of everything, at least for a while. Maybe at some point, by the way, there's only going to be the version for the machines, and we're each going to consume it in our own way. I spoke with Ben Stencil here on the podcast a couple of weeks ago, and he said, listen, at some point, AI is going to take the entire world and summarize it for us. So it doesn't matter how somebody wrote something, what language it was in, how verbose it was. You're going to get it in the version you want anyway. So maybe it's all going to be
Yeah.
machine.
Yeah, exactly. But I think for some subset of people, I think the voice and the way that things are said will be important, and you'll want to hear that. It's the way, I don't know, I really love spy novels, and there are certain authors whose voices I love. I just love the way that they write. Like there's this one guy, Mick Herron. There's a TV show called Slow Horses, and he wrote the book on all these books, and just his humor is so fun. It's laugh out loud funny for me. It's so dark and caustic, and it just makes me laugh. And I never want that summarized because that's the beauty of what he's writing. And so I really hope for at least some subset of people, there's enough skill in writing that people will read the original.
Yeah, actually, Ben is a good example. Even if you look at his most recent blog post, he called it "The Future is Orange" or something like that. But he's talking about the journeys of startups, and he's making a parallel to driving down the interstate. But he's using a lot of very artistic and figurative language that, if an AI summarizes it, it is boring. You'd lose all the color, all the taste, all the beauty of it. You would lose if AI were to summarize it.
Yeah.
Yeah.
And so if you're, just grinding through a whole bunch of stuff, it's great. But the nuance there, that's what makes life beautiful. Yeah.
Okay. So tell us a bit about like the more technical aspects of what you built. So you built this engine that is consuming newsletters. It's consuming podcasts, so tell us a bit about the mechanics of that thing.
Yeah. So the very first project I embarked on was automating my email, right? I tried the Superhuman auto respond wasn't quite getting what I wanted. And so then I started building the system, which is now underpinning a lot of the workflows. So, and it's also the same for blog post generation for the first 2 drafts of 4. And so you have the core data that is then being chunked and then put into a vector database, use LanceDB. And then on top of that, a lot of these systems, actually all of these systems, then use DSPY, which is a programming language for prompt writing. And then many of them go through GEPA, GEPA, which is a generative Pareto use. And that's a technique for optimizing the prompt in a multidimensional way. So if you care about, for like blog writing, how much data is in there, or how great is the hook, or how varied is the cadence of the sentences, how musical is it, you can specify what those dimensions are. And then there's a Python library started out of Berkeley that does this very well, called GEPA. And then all of that is sent to an evals database. And the combination of those 3, you just kind of iterate and you pick the number of different mutations. And then there's an evolutionary system that does best of n with an LLM as a judge. I'm going through a lot here, but I'll just draw you the architecture.
Yeah, we're going to break it down in a moment.
And at the end, there's an LLM as a judge that makes a final determination and decides how many more iterations to go through, and then it outputs whatever it is that you want to output.
Yeah. Okay. So, so if I kind of summarize or take the parts you just talked about. So there's something that ingests the content in, if it's in the case of emails. Then you've got your engine DPY for actually sort of basically managing the agents or the different parts of what actually works here. But then when you think about the agents, you say, okay, well, I need to build really, really good prompts. So I use, what was it? GEPA?
Yeah.
GEPA to construct the right prompts. That the idea there is to construct the right prompts that would instruct the AI to focus on the things that you care about. Is that the right way to think about that part?
Yeah, that's right.
Yep. And then the evals are there to test, right? So you're running the engine and you want to test that the results are in line with what you expect them to be. That's where the evals comes into the picture. So let's dig into these things step by step. So let's start with that ingestion of content. So either pulling in content from emails or other sources of content. Any lessons you can share there about what worked, what didn't, what you thought would work and didn't eventually, or was it pretty straightforward, that part?
That part's relatively straightforward. I mean, you need to pick the right chunking library, and then you need to pick the right vector database. It's really important, I think, to have multimodal, which is why we chose Lance, because sometimes you'll have structured data and unstructured data, and then the inference speed is also really important. But aside from that, like that's, and then the question is, do you run the chunking locally or in the cloud? And which model do you use to chunk? And I found, I run an M2 Max with a lot of RAM. Even then, sending it to the cloud and parallelizing it was really important to get it up to date. The last thing I'll say is updating that vector database with some reasonable frequency is critical. Now, like within the world of data, real time was never really a thing. But I think with a lot of these applications, like email answering or those kinds of things, it's really important to have the underlying vector database updated quite quickly in order to get the performance that you want. And you just kind of expect a machine learning model to know, like, no, I just told you this thing, or no, I just wrote this blog post, or this tweet just came out. Like you need that pipeline to come back pretty quickly. And so that was a lesson for me.
Okay. So essentially, initially, maybe the vector database was a bit stale. So, it learned a lot about who Tomasz is and how you conduct yourself, how you, your language, how you respond to things, et cetera. So it had that snapshot, but basically it wasn't in touch with the things that are, most up to date that just recently happened. And that was an issue. So you wanted the vector database to be updated, every day or something like that?
Yeah, every time. Yes, at least every day. But it depends on the workflow. So for email, it's anytime I run a local email client, and that checks every 5 minutes. And so the vector database is updated every 5 minutes.
Well, is it differential or is it full
differential?
Yeah. Okay. Yeah. So every 5 minutes, new email, then it takes them and pull them in. Okay.
That's right.
By the way, if I email you today, how likely is it that the reply that I get was generated by this engine?
0. Zero.
Okay.
It
Right.
is really hard. I have not been able to get the email system to work.
Why?
There is so much context associated with answering an email that is not immediately addressable to a human. I mean, to a robot.
Sure.
It
So
is,
all the
yeah.
stuff that goes into the vector database is not enough for that AI bot to, or agent or whatever you want to call it, to be able to actually write an email for you.
Let
That's
me give you an
incredible.
example. So, you and I know each other for 15 years or however long it is. And so I might lowercase everything in my email, right? And that will confer a sense of casualness and
Mhm.
familiarity.
Yeah.
I might know a limited partner who's an investor in the firm or who I've worked with for 10 or 15 years, and I would never
Do
send
that. Yeah.
an uncapitalized email. And that
Yeah.
nuance is incredibly hard to capture, right? And so what I found like time and time again, and then, okay, so that's one problem, which is just there's a whole bunch of context. There's another problem, which is for a really long time, like the machine generation of an automatic response wasn't working. And what I did instead then was I said, okay, I'm going to give you a prompt, and when I give you the prompt, you will then run a system that collects all of the context from the vector database. And with the prompt that I give you plus the context, then generate an email. Okay, then the problem was, well, actually, the model would sometimes interpret my email as an instruction, and it would actually go and try to do the thing, call the tool, and so there was that
Oh,
nuance that was being lost. And now I think with the next generation tool calling, that's solved. And then the most recent challenge has been, um, there's 3 people on the email. Who are you replying to? Right?
well, the person who sent the email?
Well,
No,
maybe,
usually,
but like somebody's
maybe not.
introducing
Yeah.
you.
Yeah.
And you want to automatically BCC that person, right? Or maybe you don't want to automatically BCC that person because they actually need to remain on the thread. And for you and I, it's trivial. I mean, it's just we've been trained so many times
Yeah.
and we
Yeah.
understand like, no, this is what you do. And so then I created a keyboard shortcut for automated intros to do this. And even then it didn't work with the non-deterministic LLM, and I needed to go to a deterministic rule. So I guess maybe I'll put it this way. There's so much diversity of communication that, and even with a very large database, I mean, I don't know how many tens of thousands of emails are in that vector DB. I was not able to extract like the primary components that could then inform an LLM. And candidly, I was using local models, right? So I'm using 14 to 2 billion parameter models on the machine, and none of the thinking models or any of that kind of thing. And that's primarily just for data sensitivity. But I even like fine-tuned models, and I just couldn't get it to work. So I threw up my hands.
That's crazy. I did not expect that answer at all. So first of all, on the data sensitivity side, so you're saying I don't want to use Chat GPT, et cetera. Even if I pay them, I don't want my emails, in those environments, right? Like, even if they're paid and they're guaranteed, we don't train on this, da, 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 I still don't want my emails there. I'm willing to live with the fact that I'm going to have a much more limited model as a result of that, right?
Exactly. Yeah. There's just some things where we need to guarantee sensitivity, or I just want to have a lot of, and emails is just one of them.
Okay. So what do you do with those emails? So if all those emails go into the vector DB, what is the output that this whole process that you detailed earlier, what is the output that does come out? Is it just for the blogs or what is it for?
Yeah, no, so that I sort of put to the side for now. I think, I've tried lots. I tried GPT OSS 20 billion parameter.
Mhm.
And this was at the same time I was trying a Salesforce model called XLAM, which is a 8 billion parameter large action model, which is just focused on tool calling to kind of separate this out. So the short of it is I've set the project aside because I guess maybe put it a different way, I've been watching how Google is modifying their email responses, and they're improving, but they're still not great. And so I have to look myself in the mirror and say, if Google with every email I've ever sent in my life is still having problems, then like, what am I doing? My little
Yeah.
machine typing away on some tiny
Yeah.
subset.
Okay. Okay. That makes sense. That's a legitimate way to look at it. Um, okay. Now, recently you started talking about the whole concept of changing, changing your flows from little bricks that are sort of making together flow to something that's a lot more composite as a way to improve the answers of the AI. So for those who haven't read those posts yet, what were you trying to do? How was it built? And then why did you end up deciding, thinking I want to bunch these things together?
Okay, so there's two value propositions of a large language model. The first one was, let's take everything that we know in the world and compress it into this little thing so it can answer me questions whenever I like. The next value proposition is do stuff for me. And doing stuff for me means calling tools. And, I'm sure like many software engineers was raised in this like Unix philosophy. You design a tool to do a very particular thing, like open a file or send an email, and you chain them together in this notion of composability. So if I want to read a file and then email the file, I don't build an end-to-end app to do that. I just build one reading tool utility and then one to send the email, and then I chain them together with a pipe, Unix pipe, and it's brilliant. And you can do all kinds of things like that. And so when I started, it was over July 4th weekend. I can't remember what model had come out, but it was some new release. And I said, okay, I'm going to try to automate as much of my workflows as possible. And so I ended up writing about 35 tools over July 4th weekend. Read email, send email, draft an email, forward an email, archive an email, and search for an email. And I wrote them as in the Unix philosophy. So each of these tools were small, had a single purpose, well documented. And I had like 30 to 40% tool failure call rates. 1 in 3 times.
Wow, that's crazy. That's very hot.
It's really, and I updated the memory. I was doing all this in Cloud Code. So I was updating the cloud.md file, and I was managing that very aggressively. And still the failure rates were pretty significant, particularly in the longer the session, the greater the failure rate. And if it had not done it before, then, so I tried the large action model from Salesforce, which worked brilliantly. And I said, one of my conversations with myself was that maybe you only need an action model maybe you have like an action model that selects the tool. And then you have a larger LLM in the case of you need some more context about what's happening in the world. And then pretty quickly I realized actually it doesn't work, because when you give a command, you provide an edict to a large language model, you are implicitly assuming, like a person, that they know a whole bunch of stuff, right? Like if I tell you like, hey, do you mind grabbing me a coffee at Blue Bottle? And we've worked together for 10 years, you might really know that I like chai lattes. And so when I ask for a coffee, it's a chai latte. And so I just take that for granted. And so that ends up happening. Like you want to talk, especially because I dictate to my computer most of these instructions. Like I want to talk to and so I assume there's not. And so a large action model by itself is not sufficient to have all of that context. And you may need stuff from like the CRM or your email or whatever. And so that didn't end up working out. And so I just kind of went along like this, where I would expect that there would be a 30 to a 40% failure rate on tools. And then Anthropic, I think 10 days ago, published this post that talked about how actually you don't want many tools. You want one very single large tool. And that large tool should have lots of flags. So a simple command might be send email, but the flags might be, here's the recipient, here's the BCC, here's the date, here's the attachment. And so you can have 15 to 20 different flags. Like the classic implementation or the tool that has the most flags that I've ever seen is this thing called FFmpeg, which allows you to convert images and video.
From anything to anything. I've used
and
that.
It is, I mean, what a piece of software, right? And completely, I mean, a Rube Goldberg machine of Unix code. But an LLM will rip right through it, right? So convert a MOV to an MP4, LLM's never been happier. And so the Anthropic guidance was build systems that look like this. And so I converted it to that system, and it worked much better, like 10 or 15% failure rates, significantly faster. And then Cloudflare published a paper a week ago that said, do not write your tools in the form of Unix commands. Write your tools in the form of TypeScript code.
Okay, why?
Because the large language models have many, I mean, like orders of magnitude more training on TypeScript than they do on Unix. Think of like how many Unix files exist on GitHub.
Yeah. And versus how much code exists there.
TypeScript.
But they,
And so you want to write this like wrapper script that underneath the LLM is writing TypeScript that then execute this really large fancy tool. And that has worked really well. It's worked really well both in terms of accuracy, so maybe like 5% failure rates. There's an incredible amount of token caching that you can do. So we observe 30 to 40% token caching rates, which input tokens drive about 98% of the costs associated with large language model inference. So that's a really big deal. And then it's just really manageable. I think the hard part is it's less and less human interpretable, but I will take that trade.
Okay. So first of all, are you mixing the TypeScript and that bunching up of tools together, or are these mutually exclusive options?
No. So that was my progression. So now I have 4 or 5 like large tools, unified tools is what they're called, 4 or 5 unified tools. Each one of them is around a particular database. There's a CRM, there's an email, there's a Notion, there's like social media, podcast, that kind of thing. And then inside, there are basically TypeScript function definitions that the LLM then generates and then executes at runtime.
And how does it know how to generate those TypeScripts? So what's the context of information it has around that?
So it has documentation in the claude.md folder in my root level, in my home level directory that it reads when it starts. And this works really well.
Amazing. Okay. So you started from having, 4th of July, broke it into a million different tools. That didn't work. 30 to 40% failure rate. That's a disaster. Try different things, but ended up basically saying, okay, I'm going to bunch a lot of actions into less tools. And then I'm going to wrap it with TypeScript. And now something like Claude Code will know how to do that because Claude code generated on TypeScript, et cetera, would be very, very good at that. Are you still using the same components we talked about earlier in terms of how you're generating the prompt and how you're doing the evals and separating the edges? Like, is that still happening underneath and driving the creation of these tools?
Yes. I mean, when there are prompts necessary, I still use DSPY and GEPA. Okay. I think machines are now much better at generating prompts than I am to get the output. Mm-hmm. And so if you can show it 3 or 4 different examples of what you want, and then I'll give you another example, like coding a web front end is now really easy because you say, okay, let's make a plan. And I think, let me take a step back. Most important thing to do with any of this stuff is first to make a plan. And you make a plan with the LLM and you say, this is what I want to do. Ask me a whole bunch of questions about what I want. And then if there's some judgment, like a PRD.
Is that like a PRD basically, right? A product requirement definition document. Yeah.
So you start with a PRD, you have it ask a whole bunch of questions. You ask it like, what haven't we covered? What else? And then you might ask it for like initial implementation. How are you thinking about implementing this? And then anytime there's a prompt, you say, here are 3 or 4 examples. Research online to see if there are other examples of similar user interfaces or whatever output you want. And then suggest to me a prompt. And then you read that prompt. Now you spend all that time up front. And then you can let the agent go and code for, I think my longest is like 3.5 hours. It'll just go by itself.
Okay.
And then the other part of the PRD is testing, putting a testing, like make sure it satisfies this condition, make sure it satisfies that condition. And then we'll go off and run. And the goal then is, okay, how can I have as many of these things going simultaneously? And the hard part is your brain. My brain is not wired to do this. This is such a weak muscle. And this is why, a completely other tangent, I think delegation is probably the most valuable skill coming into this next wave of work, which is I need to be able to delegate all of these thoughts very effectively in a way that can be interpreted. But that's the way that it works, or that I use it at least.
But you're investing a lot of effort up front, describing what it is that you want. And it's something that we humans were always trained to do. PRD, for example, it exists for a reason. But in our interaction between humans, we kind of got used to the fact that, we can figure some stuff along the way, and, we'll get on another Zoom call and do another Slack chat to answer 30 questions, et cetera. Your point is you got to very heavily front load the thinking, like that PRD, like that plan. Then AI is really good at building AI at this point, right? So if you give it enough information, then it will build the right prompts. It will build the right tools. It will put them together. It will build the code around that. And we have great tooling for doing this. So you can create something that is largely reliable, 95% reliable in terms of the tool call actually working and doing what it's supposed to do, right?
Yes.
That's like a good way to summarize that and think about it. Okay. Now we started the conversation from you saying part of what you're doing here is to learn what gaps exist in the market and what points of friction, et cetera, and where maybe people will need solutions and products, et cetera. Because at the end of the day, you are a venture capitalist. You invest in startups. So from everything you just learned, how does that impact where you're looking to invest or the companies you're looking to partner with, et cetera? Like, have you seen these two relate, or is it too far off?
Yeah. So I'll give you an example. So through all of that rigmarole over the summer, we discovered that it's very difficult to debug a tool call.
Yes.
In fact, I don't know how to.
Mm-hmm.
And that's a big problem. That's a really big problem because any enterprise system, any agentic enterprise system will call lots of tools. In fact, we've talked to startups where certain workflows might call 33 or 35 or 40 tools. And today, you just throw a prompt into the system and wait for it to come out the other side, which there's power there, of course. That's why these systems are so beautiful. You're basically like wiggling one side of a rope and it's going into a box, and then you're trying to figure out, can I get it to wiggle the other in the way that I want? And that's hugely frustrating. It's hugely frustrating. So there's a big problem to be solved there. How it's solved, whether it's through interpretability or observability, I think it remains to be seen, but it needs to be solved.
Yeah. We, so at Solid, behind the scenes, we also have a lot of tools getting called. And for example, for the planning part, we are using a smaller model because it's better at planning. Just the points you said, we use LangGraph and LangSmith. So LangGraph for the, agent orchestration and LangSmith for observability. And it's amazing. Every single call, get full observability. Every single tool, what was the inputs, the outputs, the session that, that sort of transpired along the way. So you get insight into what's going on. There's still a challenge that it's very hard to trace through. Like, programmers are used to being able to do step into, step over, like, F8, F7, F8, depending on what your IDE is. In here, all you're getting is like basically the printfs organized in this tree and graphical, but so basically printfs. And you're like, okay, now let me try to figure out what on earth happened here. So are you actively now thinking about, okay, I would like to look for a solution that can integrate into agent orchestration and do debugging and, I don't know, breakpoints and steps and things like that? Is that what you're thinking?
I don't know if that, I think maybe put it away. The problem needs to be solved. And now the question is, who solves it? Is it a foundation model company that has ability to go deep within these models? Or is it the domain of a startup? And then the second is, what is the technology that's used to solve it? And one of the questions about this category, we saw OpenAI release a basic form of evals yesterday.
Mm-hmm.
Closing the loop in these systems is really valuable because if you close the loop, then the accuracy is better, right? You want those feedback loops, and you can replicate this at small scale, but at big scale, it's even more powerful because of the data network effects. And so I think one question about all this is, is this in the domain of the foundation model companies who will compete on right now? I mean, the nature of the competition is all around accuracy and tool calling. And that's a big thrust for the infrastructure teams within these models. And if that's the case, well, I mean, they will run into the same issue. And do they eventually just release a tool that's a component of their overall portfolio? So that's still an open question. We don't have an answer there.
Would you, if you had to take a bet, like, for example, let's say today a company comes in and says, okay, we're doing debuggability for running tools, et cetera. Is your intuition like, okay, there is room for a startup like this and it can build a big market, et cetera? Or, well, this is square in what OpenAI would build for themselves and Anthropic would build themselves. So, I expect them to deliver on that. Like, what's your intuition there?
Yeah. So there's a very small number of people who are domain specialists in a field called interpretability.
Mm-hmm.
And if a startup came in and had the vast majority of interp people, then yes.
Yeah. Okay.
Because then you have a monopoly or a quasi-monopoly. And that's a very, a lot of that is still research, right? So what is interpretability? Well, if you're a neuroscientist, you can open up a mouse's brain and poke a neuron and it'll fire the left arm. You can do that for large language models too. And current state of the art says, okay, well, when you talk about a lion, these neurons within a large language model fire, and you can use another large language model to figure out, okay, these are the lion-related neurons, but we still can't control or modify. And so there's a lot of just the way that neuroscience is researching how brains work. It's an analogous, not identical, but an analogous domain. And so, yeah.
Yeah, there was a conversation with so Anthropic have a lot of the inter people and they do a lot of experiments. So one experiment they did, I think it was like 2 years ago, is so, in your parameters and your weights in LLMs, it's sort of like your neurons as you described. And they messed with one of them. And what they did was they found the ones that were around the concept of the Golden Gate Bridge. And they amplified that one. And then what happened was almost any question or any prompt you gave that model, it somehow tied it back to the Golden Gate Bridge. So it was exactly that. And there was this discussion between the guy who was working on it and an actual neuroscience guy who was like, the neuroscience guy, the best they can do is shove electrons and things like that. The people that are doing the interpretation in AI can actually mess around with the neurons and see what happens. It was amazing to see. And, there's a lot more to learn, but yeah.
Yeah, so it's really cool. I mean, I think if you are lucky enough to be in a PhD program in this domain, it's an incredibly exciting time.
Yeah, amazing. Debuggability is a major thing that you said. You walked away from this experiment, this summer of love, summer of AI. You walked away and said, okay, debuggability, big problem. What else? What else came out of all of that?
Well, I think understanding vector, we invested in LanceDB after going through some of these challenges and really feeling them firsthand and what multimodality is. Other categories like tool design is a really important one. MCP will be a really important and I think a critical technology here. And that's all new. All of it is new. The security components of it and observability components, and that's all getting figured out now. So we're spending some time there. Yeah, those are two of the categories where we're spending time.
So MCP, for example, we've seen a lot of various security issues recently, like people who are sending other people calendar invites, and there are certain settings in Google Calendar, but you can get an invite to get automatically added to somebody's Google Calendar if they didn't block it in advance. Now, if that somebody then uses ChatGPT and connects it into their Google Calendar and asks ChatGPT a question, it is possible that ChatGPT will read that invite that you pushed into their calendar, and then that will impact how ChatGPT is behaving. And there's like a whole security issue around that problem. This came up a couple of weeks ago. So are you thinking about those kinds of things when you say MCP and security, or are you thinking about other?
There's just so much surface area. There was a video of a guy who sent himself a Google Calendar invite that had a prompt that opened and closed all of his shades. And did you see this? Shades and his lights. And then he asked Gemini, hey, what's on my calendar for tomorrow? And then all of a sudden his house starts going crazy. So there's definitely that component. Data loss prevention, classic component of security. Access is another really critical part. And then just like, Sandbox, one of the brilliant parts of Codex, which is the OpenAI's coding agent, is that it develops within sandboxes. And so the blast radius of something going wrong is quite small. So you can imagine the equivalent. Okay, a sandbox is for MCP, just before you ship stuff in production. What is it? But all of this is new. I think it's initially, I had a naive view that MCP security would be enforced at the API layer. That's not true.
It's not. No.
There's just too much added complexity. And then you have, the whole non-human identity. Do I treat an agent as another human human equivalent account where I onboard and offboard that person? And, so there's just so much to be, it's all dark. My point is it's all dark and there's no shape to the solutions. There's no shape to the buyer desires yet. Because, we ran an analysis of MCP servers that we published, 75 to 80% of them are still just core infrastructure manipulation. Spin up this particular node on this particular infrastructure as a service vendor, look up this documentation, search for that. And so there's no application level usage. Yeah.
Yeah, just like the API that for infrastructure that you could do through Terraform or normal API calling, et cetera. And it's just MCP is just another way to do it.
Exactly.
Not so much application usage of actually applications talking to one another, exchanging information and being used together.
Yeah, we're in the era of websites within mobile apps. We're not in the era yet of native mobile apps.
Yeah, makes sense. So if you're talking about that, if you think about the challenges of, the businesses that eventually are going to buy products made by these startups or by these bigger companies, are we maybe building too early? Are we,
No,
wait?
let's build faster. No, I mean, yeah, I think we will see. I mean, we saw again with like the OpenAI. I think there's an implicit adoption of the MCP standard there with their
Yeah.
applications. I think that the adoption of that standard in particular is just about to explode. Um,
Mhm.
and it will happen in consumer, it'll happen in B2B, and so we need to be building here quite aggressively.
Yeah, already. Like been getting into that already. Okay,
Yeah,
interesting.
you need to be paddling ahead of the wave for the surfers out there.
Yeah, yeah. Okay. I'm a learning surfer, so I'm still trying to stand on a wave for more than a couple of seconds.
Yeah.
I'm getting there. I'm getting there. Uh, okay, great. So we have this portion where I'm going to ask you a couple of rapid fire questions. But before we go into that part, anything that going into this episode, you were thinking, oh, it would be great if we covered X, or we shared Y, or there was some learning that I really want to share with the world, and I think this is another avenue to do that. Was there anything like that kind of came to mind that you wanted to include?
Just one other thing that I learned over the weekend. It is,
Mhm.
and you talked a little bit about, Yoni, having a model that plans and another one that executes is really important.
Mhm.
And you don't want shared context between the two. That was not obvious to me.
Interesting. That we discovered that through experimentation. We figured out, so we were running different models. So there's the planning, there's the different tools, et cetera. And then we just tried different models, and we just noticed that the smaller, simpler models were really good at planning.
How small is small for you? Is it like 8, 14, 30?
So in that case, it's I don't remember which one of the minis it is, but it
It's a
is an
mini. Okay.
OpenAI, one of the minis ones.
Okay.
It's not like the bigger ones, and it's not, it's not 5, et cetera. It's I think it was like 03 mini or something like that.
There's just less stuff in its brain, right? And
Yeah,
so
yeah.
yeah. Okay.
I think it confuses itself less, right? It's like it makes the task simpler for it to be able to work up. Okay, so right, lightning round, just a few questions. Try to not think much when you're answering. Just answer whatever comes to mind, and then explain what
Reflex
it is.
answers. Okay.
Exactly. AI tool you can't live without.
Cloud Code.
Why?
I live in Cloud Code. I use the terminal more than I use my browser.
Amazing. Why not Codex?
God, Codex drives me crazy. It's always asking for networking permissions, like to access the internet. I mean, like I love the sandbox model, and sure, in certain situations it's great, but like the amount of times it raises its hand and it needs help, it's like
You're like a very junior developer. Like I can't deal
oh
with
my
it.
gosh, it's just like
I
no,
hired wrong.
just go, come on.
Yeah, I hired wrong. Okay. An AI myth you'd bust in one sentence.
Oh, the doomerism. I think
Explain.
there's just so much doomerism around AI, and people point to the destruction of jobs. And so it's like, yeah, but like, okay, the Industrial Revolution, the phone, the television, the radio, the car, the dishwasher, the automatic dishwasher, the robotic vacuum, and all of these innovations have really improved my life, and yet have not destroyed huge swaths of the economy. And then, I think this like fear, and no doubt there are national security risks associated with AI, just like any sophisticated technology. The HAL 3000 self-destruct. I mean,
Okay.
if you use this stuff, just use it. Just use it, and you'll know like how like it's like it's like a T-shaped person. It's like brilliant in one axis, but like completely helpless in another domain. And so I think, like this is a really awesome, super productive technology that is like the car in 1900, where you put in a gallon of gasoline and you can go like a tenth of a mile.
Yeah.
And there's no
Yeah.
suspension, and there's no catalytic converter. And
You need to crank
yeah,
it going.
I mean, we're so far from what these systems will ultimately be able to do that I think the internet benefited greatly from this period of safe harbor, where a lot of innovation was allowed to flourish with legal protection, and something similar needs to exist for AI with reasonable constraints, of course. But I think the doomerism is misplaced.
Okay. Yeah. Okay. Favorite book, podcast, or resource for builders?
Oh, How to Do Science and Engineering. I love that book.
How did
Trike
you?
Press, really great.
Okay,
Just a philosophy of how to build things. Brilliant, brilliant book.
interesting. I haven't read that. I need to have that. One last one. One prediction for AI in the next 5 years. Although you touched on it a bit, but if you had to articulate it
One prediction for AI.
in the
I
next 5 years.
think, I think it massively benefits people who are effective multitaskers.
Okay.
I think the people who can manage, like the skill, I initially thought it was a vanity metric, but so let me give you a story here. I met a computer scientist and asked him, how many agents can you manage? And he said, I can manage 15 simultaneously. And that blew my mind because I can get to 4, maybe. And then I saw a visualization of a software engineer managing 150 agents. Looks like a radar. And so I can't tell if it's real or not, but even if it's science fiction, it's an inspiration to a new way of working where
Mhm.
it's like a manager. If you're a director at a large company, you manage 150 people or
Yes.
you manage 2,500 people. And no, you don't know what Tomasz is working on Tuesday morning at 10 a.m. And you've given a broad enough direction that's then been delegated and filtered down to the ultimate execution, and there's intermediate management. Well, what is that tool calling system that you mentioned, Yoni, where you're calling 100 tools? That's no different.
Yeah. Well, but you need to build layers into it. So when somebody says I can manage 150 tools, essentially there has to be layering into it. So there's like these manager tools, and then there's team lead tools, and then the actual tools that doing the work or agents, and that maybe is a way to deal with it. Because I think about it, I can multitask, but also maybe the number of cores I can get to, a number of threads is probably like 4. So, much like you. So I don't know how we get to 150, but only maybe through that sort of hierarchy.
Yeah, you need that pyramid.
What's interesting because, you know, eh, the recent human history hasn't been very favorable, at least partially, to people who had, sort of attention related disorders, or, needing to, people who spread their attention. I wonder if maybe it's an opportunity for them because, being able to spread your attention across 15 different things might be even actually something good in that kind of scenario. So,
Yeah, yeah, it could be. But I do think this idea of very sophisticated delegation is one of the. I mean, all of us are debating what do we teach children? Extremely sophisticated. I mean, great writing still
yes.
remains important.
Yeah.
Systems design remains really important, and then effective delegation and communication.
Yeah.
Those are my 3.
Yeah. Yeah. Articulating what you want in a way
Yeah.
that at the end understands and can run with it is still super, super important, and even more important at this point. Amazing. Tomasz, this has been a real joy. I really appreciate you coming. This was super interesting.
I had a blast. Thanks for inviting me on, Yoni. Yeah, really enjoyed it.
Thank you. Have a good day.
You
See
too.
ya.
Bye.
Thank you. Bye bye.